a few more debugging tips for those of you who want just a few more thoughts. I want to say that if you're getting JSON errors, there's a couple of possible, it always boils down to your code's using too much memory. If you're using a GraphDB to store the results of A star, that is, you have nodes which have previous pointers, that kind of thing, I just want to reiterate, you got to be careful. If shortest paths changes anything in GraphDB, you got to reset it when you finish shortest paths. I've seen this quite a lot of times. So if you're getting JSON errors that only happen when you have shortest paths in your code, this is quite possibly why. Now, that only applies if your GraphDB stores results of A star. There are other ways this can pop up, but the idea is that it's some kind of infinite loop in your A star. I should mention there's another cause of JSON errors in the autograder. That is, if you don't have shortest paths, like you comment out all the code and it still crashes, it's probably that you have too much stuff in your GraphDB. That's something someone mentioned at office hours. Okay, and lastly, I should say that if your routing code is somehow giving the wrong answer, but you feel like you've been fighting with it or whatever else, try just getting rid of stuff that only serves to speed up your code. So if you're doing approach 2 or 3, comment out the idea of a mark set. You don't need a mark set, right, for it to work properly. And maybe you'll even pass the timing test. If it doesn't, then you can try and add mark sets back, but they're not necessarily super important. For approach 1 and 3, where you're updating priorities, well, switch from a login priority update that's hard to get working to a linear time priority update that's easy to get working, and that's the approach where you just delete the old copy of W. And then lastly, maybe you're having some trouble with some other more subtle issue. Well, you can turn your A star into Dijkstra by giving every vertex on the priority queue a priority which is equal to DSV plus ed VW. Now in that case, you're ignoring the heuristic distance, and then maybe simplify your code, simplify your thinking, and if you can get that working, but it's too slow, then you can try and add back the HW. And then my last piece of advice is that A star is not super hard to implement whenever you have the right approach, I guess I'll say, right? So in my case, obviously I've taught this class many times, and I taught 188 where you do even more A star stuff. So for me, it's relatively quick, like almost just off the top of my head. But it took me maybe 20 minutes to sit through it. Basically what I did is I said, okay, I'm going to go through and do approach 1 to double check my code here. So I just wrote what was on this slide. It took me about 20 minutes or so, and it just worked after I fixed one silly little bug. And by the way, that silly little bug is on this list of common bugs. So what I'll say is it could be easier to start from scratch and rebuild A star than it will be to try and take something that's slightly broken and fix it, right? And yeah, my code in my case was maybe like 68 lines involving, and that includes some boilerplate stuff that just calculated priorities, like a little node class, just not a lot of, this code that's not necessarily super interesting. Okay, so that's it. I hope you have more luck with routing, and I hope you find these common bugs helpful. That's it, and I will see you in lecture, hopefully.